Definite integral. Let's discuss the properties of definite integrals. There are 6 properties in total. Let's start with property number 1. Integration from a to a fx dx will equal to 0 because we will get the same answer from substitution of a minus substitution of a. Second property, we want to integrate from a to b fx dx. So if you want to change the limit to integration from b to a, we must add a negative in front of the integral. Property number 3, integration of ab k fx dx will equal to k integrate ab fx dx, where k is a constant. Property number 4, integration from a to b fx plus or minus gx dx equal integration ab fx dx plus or minus integration ab gx dx, meaning that we can separate the function fx and gx. Property number 5, integration from a to b c dx equal to c b minus a. And finally, the last property, integration from a to c fx dx equal integrate ab fx dx plus integrate b c fx dx. We must make sure we start from the same limit a and ends with the same limit c, and then in the middle we have limit b. We are given the integration from 1 to 5 fx dx equals 3 and integration 1 to 5 gx dx equal 1. We are asked to evaluate the integration 1, 5 to fx minus gx dx. Okay, here we can apply the properties of definite integral. Number 1, we can separate. And because 2 is the coefficient, we can factorize 2. Okay, after that, use the information from above. Integration 1/5 fx dx is 3 minus integration 1/5 gx dx is 1. 3 multiplied by 2, 6. 6 minus 1, the answer is 5. We are given gx equal x plus 2 for x less equal 2 and gx equal kx squared for x more than 2. This is what we call as piecewise function. And then we are asked to find the value of k if the integration from 0 to 4 gx over 5 dx equal 4. So here we can use the properties of definite integral, where integration of a to c will equal to integration from ab plus bc. So since the values of x here is less and more than 2, we can separate the limit into 0 to plus 2, 4. 1 over 5 here is the coefficient, so we can factorize 1 over 5 and then we take gx. Equal to 4. We can multiply 5 by 4 equal 20. Okay. For limit 0 to, we choose function when x less equal than 2, so x plus 2. For limit 2 until 4, we choose the function when x more than 2. Okay, let's integrate. Integrate x is x squared over 2. Integrate 2 2x plus k as the coefficient, integrate x square x cubed over 3. Substitute 2. 2 square is 4. 4 divided by 2, 2 plus 2 multiplied by 2, 4. Minus, substitute 0, 0 plus k. Substitute 4. 4 power 3 over 3 is 64 over 3. Minus, substitute 2. 2 power 3 is 8. So 8 over 3 equal 20. We get 6 plus 56 over 3, k equal 20. And final answer, we get k equal 3 over 4. Let's discuss this example. We want to evaluate the integration from 0 to 1 to x squared minus 2x plus 3 over cube root x dx. First, let's simplify the function into separated terms. Okay. First term, 2x squared over x power 1 over 3 minus second term, 2x over x power 1 over 3 plus the third term, 3 over x power 1 over 3. Simplify each term. X divided by x, so we must subtract the power. 2 minus 1 over 3, we get 5 over 3. Okay. 2x is x power 1, so 1 minus 1 over 3, we get 2 over 3. Plus 3 x power negative 1 over 3. So now we can integrate each term one by one, starting from the first term. Five over 3 plus 1 is 8 over 3. Two over 3 plus 1, we get 5 over 3. Negative 1 over 3 plus 1 is 2 over 3. We can simplify the terms before substitute the values of the limit. Okay, first substitute 1 into x. We get 6 over 8 minus 6 over 5 plus 9 over 2 minus, substitute 0 into x. We get 0 minus 0 plus 0. Final answer is 81 over 20. Next example, we want to evaluate the integration from pi over 6 to pi over 2 cos x over sine x dx by using substitution method. Okay, first step, choose u. We choose the denominator, so u equal sine x. Differentiate u in terms of x, we get du over dx equal, differentiate sine x cos x. Okay, we can do the same for the limit. When x equal pi over 6, u equal sine pi over 6. So we can use calculator. Make sure your calculator is in radian mode. Okay, substitute sine pi over 6 equal 0.5 or 1 over 2. So when x equal pi over 6, u equal 1 over 2. Next, when x equal pi over 2, u equal sine pi over 2. So again, use your calculator, make sure it's in radian mode, and then calculate the value for sine pi over 2, which equal to 1. So now let's do the substitution. Originally, the limits are from pi over 6 until pi over 2. Now, the limits are from 1 over 2 until 1. Okay, next I want to replace sine x. Sine x is u. And then replace dx. We can take dx from this equation. So dx equal du over cos x. And lastly, insert cos x. Here we can see that we can cancel out cos x. And we are left with the integration from 1 over 2 until 1 over u du. Integrate 1 over u ln u. And because this is definite integral, next we must substitute 1 into u minus substitute 1 over 2 into u. So ln 1 minus ln 1 over 2. Which give us 0.6931 as the final answer. Next example, we want to evaluate the integration from 0 to ln 2 exponent 2t over exponent 2t plus 2 dt by using substitution method. First, choose u. Okay, we take the denominator, u equal exponent 2t plus 2. Differentiate u in terms of t, we get du over dt equal, differentiate exponent to t is exponent to t over 2. And then let's change the limit. When t equals 0, u equal exponent 0 plus 2. Use your calculator. The value of exponent 0 is 1. So 1 plus 2 equal 3. And then when t equal ln 2, u equal exponent 2 ln 2 plus 2. Exponent 2 ln 2 is exponent ln 2 square we can cancel exponent and ln. So 2 squared is 4. 4 plus 2, 6. Now let's do the substitution. Integration from originally 0. So now 3. Originally ln 2 and now 6. Replace exponent 2t plus 2 by u. And then next, I want to replace dt. We can take dt from here. So dt equal 2 over exponent 2t du. And then let's insert exponent 2t. Here we can see that we can cancel out exponent 2t, and we can also factorize 2. And we are left with 1 over u du. Integrate 1 over u is ln u. And because this is definite integral, as for the final answer, we must substitute 6 minus substitute 3. So ln 6 minus ln 3. Multiply by 2, and we get the final answer 1.3863. Now we want to evaluate the integration from 0 to pi over 6 sine square x cos x dx. First, we want to simplify the function. We can separate cos cube x into cos square x cos x dx. And then we must choose either sine x or cos x to become u. So we choose u equal sine x. Why u equals sine x? Because when we proceed to the next step, which is to differentiate u, differentiate u is du over dx, differentiate sine x, cos x. So we have cos x in the question. Next, we can also change the limit when x equals 0, u equal sine 0, use calculator, sine 0 equal 0. And then when x equal pi over 6, u equal sine pi over 6. Make sure your calculator in mode radian. Sine pi over 6 equal to 1 over 2. Okay, let's do the substitution. From identity, sine square x plus cos square x equal 1, we can substitute cos square x by 1 minus sine square x. Okay, substitute in terms of u. 0 is still 0. Pi over 6 is now 1 over 2. Sine square x, u square. 1 minus sine square x, 1 minus u square. And then cos x dx is equal to du from here. Expand. And now we can integrate. Integrate u square, we get u cubed over 3 minus. Integrate u power 4 is u power 5 over 5. And because this is definite integral, as for the final answer, we must substitute 1 over 2 minus the substitution of 0. Substitute 0, we get 0 minus 0. Okay, after some calculation, we get final answer 17 over 480, or in decimal form 0.03542. You are advised to leave your final answer in fraction form if you can, because it is more precise compared to decimal.